Hello everyone, welcome to ELAC UOPS Tutoring. I'm Kai and today I'll teach you several methods to deal with factoring. So we have factoring expressions. Okay, so there are three primary techniques that you can use to factor an expression. For example, you can factor by GCF or by grouping or just by inspection. And I'll do an example of each to demonstrate the methods. After that, and I'll do some challenging problems that relate to the properties of factoring. So the first example I have is x to the 6 minus 4x squared. So, and we're going to use factoring by GCF. So now let's break down each component. This one I have 6 x's. While the last part, neglecting the negative sign, I have 2 x's. So I can take out 2 x's out. So then I have x squared. Then I left with x to the 4th minus 4. Okay. Now, I notice that this part here can also be factored. And that relates to one of the properties of factoring, which is the sum of different square or a perfect square. So the formula for that is a squared minus b squared, which is a minus b, a plus b. So then breaking this down further, I have, now that I see that x to the 4th is x squared to the square minus 2 squared. So here a is x squared, b is equal to 2. So then by plugging back into our formula here, we have the following. We have x squared minus 2 and x squared plus 2. And because this is the most simplest form, then this will be our final answer. The next problem or example I have is 10 to the x cubed minus 8x squared plus 25x minus 20. Okay, so notice that we have 4 terms here, right? 1, 2, 3, and 4. So usually when we have more than 3 terms in an expression, we're going to have to use grouping. Okay, what does that mean? So you have to group out a common expression that you found and combine them into a simplified one. So let's take an example. Let's look at this part. So I have 10x cubed minus 8x squared. So now notice that I can factor out a 2 out because that will be the GCF. Then I left with an x squared, right? Then I have 5x minus 4. Similarly, for this last part, I can take out a 5, right? And then left with 5x minus 4. So putting them together, I have the following. 2x squared, 5x minus 4, plus 5x minus 4. Now notice that here, these terms are the same. So then I'm going to group them together. And then the rest, just keep them as one group. So we'll have, that will be our final answer. Okay. So here we use grouping. So we found the common expression and then we put them together and form a new one. Now lastly, I have the example, and it's 9k squared plus 66k plus 21. Alrighty, so now here we have a trinomial because we have three terms. Now we're going to use inspection methods, okay, to solve this problem. But before we do that, I notice how this term, the leading coefficient, have GCF of 3. So I'm going to take that one out. And I left with 3k squared plus 22k plus 7. So that will make our problem more easier and more simplified. Now, let's focus on this. So 3k squared plus 22k plus 7. Now let's look at the first term. So I know that factors of 3's are 1 and 3. Okay, so which means I'll have either k, 3k, or 3k with k, right? Because when I do the FOIL, I satisfy the first term. Now let's look at the last term, 7. Well, 7 is a prime number. So factors of 7 are 1 and 7. So now I can put 1 here and 7, or I can put 7 and or 7 and 1. Now, because these are all positive, so I'm gonna make everything positive, right? And we cannot use negative because our middle term is positive. So now let's look at the first case. So if I do FOIL, k times 3k is definitely 3k squared. K times 7 is 7k. 1 times 3k is 10k, right? So first case. So like I said earlier, this is 3k squared plus 7k plus 3k plus 7. Well, this is 3k squared plus 10k plus 7. Well, that's not what I wanted, right? So this method, that will not be our answer. Now let's look at the second case. I have 3k plus 1 and k plus 7. Again, I do the FOIL. So I have 3k squared plus 21k plus k plus 7. Well, this is definitely 3k squared plus 22k plus 7. And that matches our answer. So our final answer will be 3k plus 1 and k plus 7. Okay. Now,